Alright, so here we are with our long division with polynomials notes. Our notes are going to go through number 1, 3, 4, and then kind of this application of number 5. So long division, depending on how it was that you learned how to divide very large numbers, you may either have done long division, which is what we're going to be doing here, or you may have done some lattice something or other. So from that we're going to learn, if you haven't, or relearn long division. Because there isn't really a long division option in our assignment, or well, in Word, this should kind of be that, not necessarily a square root, but that kind of parenthesis thing, house. Alright, so either way, we're doing long division. So the idea in long division is to take this number here and kind of understand all of its multiples and see if it will go into our first number here, number 1. So since 5 goes into 0 no times, we could potentially put a 0. However, we don't usually put numbers like 700 as 0700, okay? Unless we're doing some military time or something. So either way, you can either put an X there because you're like, it's not going to happen. But of course, now we use X's as variables. So that was a great technique when we were in elementary school, but now not so much. Either way, we know 5 does not go into 1. So we do know, however, that 5 goes into 12. So what we need to ask ourselves is how many 5s go into 12? And that would be 2. Then we do 2 times 5, and 2 times 5 becomes 10. We end up subtracting these two numbers to find out that our remainder is 2. Clearly, 5 cannot go into 2, so we need to bring down our next piece, which is a 3. And now we ask ourselves how many 5s go into 23. Well, 5s into 23 would be 4. And then 4 times 5 makes 20. We go ahead and subtract that, and we end up with a 3. Bring our next number down. We get a 5. Now we're asking how many 5s go into 35. Well, that's going to be 7. And 7 times 5 is going to make 35. And 35, when you subtract, makes 0. And so we technically have this remainder 0. But of course, really the idea was 1,235 divided by 5 is going to equal 247. So I will let you do this next one in your homework. So we'll move on to this one. Notice it says that it's long division with a decimal. So we'll see what that means. Start out with the same idea. You're trying to find out how many 4s go into 3. Well, none. So then we move on. How many 4s go into 34? And again, this is whole 4s versus decimals. We'll get to that. So 4s into 34 is going to be 8. And then 8 times 4 makes 32. And so then we'll subtract. And our result is 2. Bring down our next value, so now we have 22. And we're trying to find out how many 4s go to 22. Well, there's 5. And then 5 times 4 makes 20. Subtract those out. And we get 2. Not quite done. We bring down our 5. Now we ask how many 5s go into 20, how many 4s go into 25. And sadly, it's not an exact number. So in that case, we're going to put 6. 6 times 4 makes 24. Subtract. And we get 1. And so now this is when, in elementary school at least, you just said remainder 1. Done. But of course then we started to talk about decimals. So now what happens is you actually get to add decimals to your number. So now we're saying, let's go ahead and divide this into, well, bringing down a 0. So how many 4s go into 10? And it's not 1.0. We're not using that decimal there. We're actually just going to slip it in up here, and that's it. So how many 4s go into 10? That's 2. 2 times 4 is 8. Go ahead and subtract 8, and we get 2. That's not a whole number or a 0 yet, so we're going to bring down the next 0. How many 4s go into 20? That's 5. 5 times 4 makes 20, and now we get a remainder of 0. And so it turns out that kind of our end result is that 3,425 divided by 4 is 856.25. Alright, so hopefully that makes sense. Alright, so then the next one, what we're going to do is the same process. Notice it's the same operation, okay? Only now they're saying with a remainder. So if we go back to kind of that same step, so we had 856, okay, and once we were at 856, we ended up having a remainder of 1. And this is where we actually get to say that 3,425 divided by 4 is actually 856 with 1 over 4. And so where does that 4 come from? Our 4 is the divisor, and our 1 is the remainder. And hopefully you can see that 856 is actually the same as 856.25. 856 and 1/4 is the same, because 0.25 is 1/4. So, maybe you remember long division. If you don't, you can of course take the time to do this. You can always search long division worksheets on the internet, because you are going to want to kind of have this idea before we move on to polynomials. So here's polynomials. Same idea, we've got kind of a large thing divided by a smaller thing, okay? And so when we put it into where it goes, this divisor goes in here, and this dividend kind of goes underneath here. Again, not a square root, this is just our symbol of long division. So, going back to our first example, what we did was we said how many 5s can go into 1, or how many 5s can go into 12. So in this one, we're going to ask ourselves how many 4x's go into 8x cubed. Okay, and so instead of answering that question, sometimes you can actually just say, what is missing, right? So notice that we want to get a 4 into an 8. Well, we're missing a 2. We want to take an x and make it an x cubed, so we're missing an x squared. So again, that first question is, how many 4x's go into 8x cubed? Or, what is missing? Or, technically, you could be doing 8x cubed divided by 4x, and you would get the 2x squared. I technically definitely go with this idea more. And then, of course, what is missing versus how many go into it, because it's hard with polynomials to understand how many multiples make that up. So, another thing that we want to do is kind of pay attention to these imaginary columns. So there are columns here. And so this one has x cubes in it, this one has x squareds in it, this one has x's, and this one just has constants or numbers. Okay. So the issue with that is that if you are missing one of these pieces, like let's say this piece wasn't here, you would have to put 0x squared in here because otherwise you don't have every place value. It's kind of like saying the number 100, okay, 1001, all of a sudden equals 11. Because those two zeros just aren't there, they don't make sense. Okay, so we need to put in those 0 placeholders, just in case. Alright. So, as we move on, we did realize that this is our missing piece, and so I'm not going to put it up here. Okay, because if I put it up there, I'm putting it in the cubed column, but it's a squared. So, 2x squared is going to go up here. Alright, then from our previous problem, what did we do with the number that was up above? We multiplied it to the thing that was outside. So we're going to multiply this to the piece that's outside, which includes this piece. So our result is going to be 2x squared times 4x, which of course we just got from 8x cubed. And then 2x squared times negative 5, so that's going to be negative 10x squared. So just to recap, 8x cubed divided by 4x, so that leftmost thing and this leftmost thing, divided, made 2x squared. 2x squared goes into the x squared column, and then we multiply it out. Okay. Then what did we do? Well, after we multiplied it out, we subtracted. So let's go ahead and subtract. This is where it gets a little bit more interesting as well, because you actually need to subtract, and it might be subtracting a negative, so we need to be careful. So 8x cubed minus 8x cubed is 0, and that's what we want. We want it to kind of go over in that slanty kind of idea like we have over here. So we've canceled that row. If we don't cancel that row, then we didn't get the right factor. So you're going to have to go back. All right. Then the next one is going to be negative 10x squared plus, because of the two negatives here, 10x squared. So what is negative 10x squared plus 10x squared? It's 0x squared. So now we need to figure out how many 4x's we need to make 0x squared. And sadly, it's none. So we're going to take 0x. Sorry, I forgot the next piece in purple, which was to bring down the next one. So we bring down 4x. Okay, still looking all the way to the left, so again, how many 4x squareds go into 0x, and that's none. And that can happen in some of these, right? It happened at the beginning of all of these, so we didn't necessarily put a 0, but we didn't put anything. So 0 times 4x makes 0x squared. 0 times 5 makes 0x. And so we are going to subtract this and get 0, which again we wanted, and then 4 minus 0, which will just be 4x. Alright, hopefully from here you can see that in order to get from a 4x to a 4x, we need a 1 in our number column. I did it again, I forgot to bring down the next piece, which is negative 5. Then we multiply this 1 in to each of the pieces, just as we did for the 0. And so 1 times 4x makes 4x. 1 times negative 5 makes negative 5. And now we're going to subtract, which leaves us with 0 and 0. Alright, so what we're going to say is our divisor, so if we take that 8x cubed idea, divide it by the 4x minus 5, we end up with 2x squared plus 1. Technically, you could say plus 0x, but that seems redundant, so we don't really need to. I do recommend you trying the next one, kind of having this sitting there, okay? So as you move on to your assignment, which is in this as well, it's probably best if you go ahead and have this step here, okay? Maybe even using the colors or whatever. So this is kind of a lengthy process, and once you frustrate yourself enough on solving it, you can always watch the video looking through how to work through them.